everybody. I wanted to spend a little bit of time doing some sample Chatelier's principle problems. And so these videos I'm going to take problems one at a time. You can pick and choose some, and they're right out of the textbook. Okay, so the first one, or the one that we're going to do right now, this is going to be, we'll do 15, we'll do this one right here, 15 point, if I can get that, 15.61, okay? And so it says, how will each of the following changes affect an equilibrium mixture of the three gases? So what I'll do is I'll pull up my this, and so let's see. This is chapter 15, just so you know. 15 and question 6.1. So there's the reaction. We should probably write the reaction down. So it's, let's see here. So it's 2SO2 plus, make sure that I have it right, O2. O2 is in equilibrium with SO3, and that is 2SO3. Now those are all gases. Okay, so I'll put that in there. Gas, gas, gas. Okay, and then what does the question say? It says, how will each of the following affect the equilibrium mixture of the three gases? So O2 is added to the system. So in this case, what we're going to do is we're going to increase, and this is the way I do these problems, so we're going to look here and we're going to increase the concentration there. Well, Chatelier's principle says that in order to, not in order to, but when there is a stress on the system, you shift to alleviate the stress. So what we have to do is, because we have a stress on this system, the reaction is going to kind of shift to the right in order for the system to regain equilibrium. Okay, and so for part A, if it shifts to the right, that means that the concentration of SO2 is going to go down. The concentration of O2 is going to go down, and that means it's going to go down from the concentration that after we added it. It's going to go down because some of it's going to react away. And that means that the concentration of SO3 is going to go up because we're making some of that. Okay, so what's the next part? The reaction mixture is heated. So in this case, whenever we have temperature, we have to look at what the delta H is. Unfortunately enough, look, we have a delta H right there. The delta H in this case is less than 0. Okay, so let's go here. Let's try to figure out what that means. When delta H is less than 0, delta H is less than 0, that means that delta H is negative. If delta H is negative, that means it's exothermic, it's giving off heat. So that means that heat is on this side of the equation. Okay, now let me just double check. Okay, it says that the mixture is heated. Okay, so now once you have that figured out, now we can do this in kind of the same way, and I'll do it in a little different color. So this is going to go here. So again, Le Chatelier's principle goes to alleviate the stress on the system. Okay, so it's going to shift this way. So now, in this case, for part B, okay, in part B, we have increased, we have SO2, O2, and SO3. The SO2 has increased, the O2 has increased, and the SO3 has decreased. Now, what is the effect on the equilibrium constant? Well, K is products over reactants. So the products has gone down, the reactants have gone up, so that means that K has gotten smaller. Okay? So what's part C? Part C, the volume of the reaction vessel is doubled, so we're increasing the volume. Okay. Okay. So we're doubling the volume. So now when we're doubling the volume, I'm going to end up running out of colors here, but that's okay. When we double the volume, that means there is more space that needs to be taken up. So this side of the reaction has 3 moles of gas. This side of the reaction has only 2. So because there's more space that it needs to fill up. So the reaction is going to shift to the side with more moles of gas because there's more space. So in this case, for question C, the concentration of SO2, the concentration of O2, and the concentration of SO3, let's see, this is going to go up, this is going to go up, and this is going to go down. Okay, whoops, wrong one. Okay, now for D, a catalyst is added to the mixture. Okay, so for D, I guess I'll do that in black. Okay, there's no effect. A catalyst is only used to change the speed of the reaction, not its equilibrium concentration. Okay, what I have a tendency to say is it affects kinetics, not equilibrium. Okay, so because it's a catalyst only speeds up the reaction, so there's no effect on the actual equilibrium position. It gets to the equilibrium position faster. Okay, and then E, the total pressure of the system is increased by adding a noble gas. Okay, well, this is kind of an interesting thing. Okay. And that's interesting because when you add a noble gas to the mixture, noble gases don't react. It could be any inert gas. It doesn't have to be neon or argon or one of the noble gases. The point there is that changes the pressure of everything equally. So the ratio of the pressures will stay the same. So if the ratio of the pressures stay the same, then that means that also has no effect on the equilibrium position. Okay? Has no effect on the amount of stuff there. So for E is also no effect. Okay? So let's look at the last one here. Okay? It says SO3 gas is removed from the system. Okay? So now we'll do this one. Let's see. I guess we'll do it in red. Okay? Maybe we'll do it in this funny purple thing. Okay. So now we have decreased the amount of SO3. So because we have taken away, now the system is going to shift to fill the gap. Okay. And so, we do this sort of thing. Okay. And so now the reaction is going to shift in this direction because it's going to fill this hole that is being left by the absence of the SO3. So the answer for F is going to be, let's see here. So if we're trying to figure out, so for F, I'm going to write it in this because it's a little easier to see. So F, the concentration of SO2, the concentration of O2, and the concentration of SO3. Okay, so it shifted to the right. So that means that this went down, and this goes up. Okay, and that goes up from the point, this point where you took it away, and then you're gonna add to it because the reaction is going to shift here. Okay, so that's how you would do question 15.61. Have fun.